The key to truly smart NPCs isn't picking one AI system, it's mixing them. We've already seen how state trees can replicate the power of finite state machines and behavior trees. Now, we're taking it one step further by adding GOAP, giving your NPCs the ability to plan and make decisions on their own. Let's build a system that combines the best of both worlds. Let's quickly recap the core concepts from part 2. We've started with the hybrid approach, using a state tree for state management and behavior trees for complex behaviors within those states. This gives us several advantages. The state tree manages states while the behavior trees handle the how of behaviors. You can quickly see exactly which state you're in and what behavior is currently running. You can optimize individual behavior trees without impacting the overall state management. But what happens when we ditch the behavior trees completely and build everything inside a state tree? It means a more structured, hierarchical approach to NPC control. Now, everything from simple animations to complex actions is dictated by the current state. By building all this logic within a state tree, we can create a predictable, controlled NPC. It's less flexible than combining it with behavior trees, but it's incredibly efficient and easy to understand. Crucially, it creates a believable and immersive experience. Now, let's add GOAP, or Goal-Oriented Action Planning. Instead of telling your NPC exactly what to do, you give it goals and let it figure out how to achieve them. Think of it like giving someone turn-by-turn directions versus simply telling them where to go and let them choose the route. Traditional AI often relies on hard-coded state machines or behavior trees, but these can be rigid and may struggle with unexpected situations. In contrast, goal-oriented action planning offers a more flexible and dynamic approach. It allows AI agents to think about what they want to achieve and then plan how to achieve it. What are the benefits of using GOAP? GOAP creates AI that doesn't just react, it plans. This leads to surprising and believable behavior that feels less scripted. GOAP AI can adapt to changing circumstances. If a planned action fails, it can recalculate it and find a new path to its goal. GOAP systems are modular. You can easily add new goals, actions, and NPCs without rewriting the entire AI system. By making AI agents feel more intelligent and responsive, GOAP can significantly enhance player immersion and create a more engaging gameplay experience. Now, what if we combine GOAP's dynamic planning with state tree's modern hierarchical state management? Imagine an NPC whose only job is to patrol back and forth. Simple, right? But what if we want them to react to a changing world? What if they see a dropped item, or get attacked, or need to warn others? Suddenly, that simple patrol becomes a lot more complicated. Traditional methods quickly become a tangled mess of if and then statements. Instead of telling the NPC how to react, let's tell it what it wants to achieve. These are goals. Maybe the goal is to find food, protect the village, or escape danger. The NPC doesn't care how it achieves the goal, just that it does. To achieve these goals, the NPC has a set of actions. These are things that it can do. Gather berries, attack enemy, run away or build shelter. Each action has a cost and changes the world in some way. Here is where the magic happens. The NPC's brain, using GOAP, looks at its current situation, its goals, and available actions. It then figures out the best sequence of actions to achieve its goals, minimizing cost and maximizing efficiency. It's like solving a puzzle. Now, let's see it in action within our level. Our goal is simple: prevent the player from reaching the exit. Let's see how our two guard NPCs use GOAP to achieve that. I'll leave a link in the description for the project files. Our first guard starts in an enclave, positioned to intercept the player at the first left turn. Let's look at the available actions. Initially, the guard is in a guard position state. It's passively monitoring the area. The second guard is positioned near the exit, acting as the final line of defense. Its actions are similar to the first NPC and also in a guard position state. As the player moves down the corridor and approaches the first left turn, NPC 1 sees the player. This triggers a change in state. The planner kicks in. The NPC assesses the situation. Prevent player escape is the goal. Guard position is no longer the best action. Engage player is now the most efficient action to potentially block the path of the player. The NPC engages the player. The player manages to slip past the first guard. This is where things get interesting. NPC 1 now has a crucial decision to make. It still has two potential actions. The goal remains prevent player escape, but each action has associated cost and benefits. Engaging the player is expensive, but no good if the NPC does not see the player. Then there is pursuing the player, which costs less, but have a better outcome of seeing the player to allow the NPC to re-engage the player. The planner opts to select pursue player. The player enters the room and NPC 2 sees the player. NPC 2 now has a crucial decision to make. It has two potential actions. Since NPC 2 sees the player, there is no need to select pursue player. The requirement for selecting pursue player is that the NPC lost sight of the player. Engage player only has a requirement of seeing the player to fulfill the goal prevent player escape. NPC 2 engages the player, forcing the player to react. Why is this so powerful? It's no longer just about reacting, it's about strategic planning. Different combinations of actions can lead to different outcomes, making the gameplay more unpredictable and engaging. This creates a more compelling and strategic gameplay experience. Are you experimenting with hybrid approaches? And if so, what combinations are you exploring? Let me know in the comments below. See you in the next one.